Hello all, welcome to my channel. This is a particular use case in a networking industry that we are going to discuss today, where there is a slightly complex scenario which we are trying to code in R and also in Python. So what happens in a network industry is occasionally there is always a network failure in between. The connection status goes off. Sometimes it is just for a transient phase for just a few seconds or a few minutes and then it comes back. But sometimes it goes for a longer duration. And longer duration, it could even mean a few hours or a few days as well. And then it again comes back normal. And then we have a normal network usage going on. And then suddenly, after a few days or a few weeks, we again have this problem. So in this data set, what we have here is we have a timestamps here, timestamps for every 5 minutes. And this is a device name. I just have used a single device here. It's just ABCD. This is just a name that I've given to a device. And we have the status and usage. So if you look at the status here, usage also I have just tweaked this number. Normally these numbers are in hundreds and thousands. So just to make it look simpler, my objective here is to just to explain how we can solve a particular problem statement that we normally face in a networking case study. When we see here the status as on, it means it is getting consumed. So there is a proper consumption of device usage. And this is the consumption, which is actually cumulative. So every 5 minutes, there is 5 units of network consumed. So these are all cumulative values which keeps increasing. But once we see that there is an off here, so there's a network going off here. But like we said, it is just a transient phase wherein just for 5 minutes the network was off and it got resumed again. So we do not see any breakage of network usage here. So this seems to be fine. But the problem lies in the fact that if I go to the next off case here, wherein the network is gone off. Now here if you see the network is gone off for quite a longer duration. It's just going on. So it went off on 27th at 11:17 and it is just off for quite some time, right? If I just keep scrolling down 27. So let me look at the next on. So here it is. So almost for 3 days the network was off and this number remains static throughout that period. And then once the network is on, it once again starts getting the cumulative values here. So again 5 units consumed, then another 5 units. So that's how this is going on. And again if you go back to the next off here, and this is a transient off, so there's no issue. Another transient off, but here again if you see there's a off here for quite some time, so the network usage remains static as it is. And once you go back to the next on case, it again starts increasing. So this is the usual trend that we see in a networking issue. Now our problem statement is, let me create a new variable here, actual usage. So actual usage is going to be just what we have here. Ideally, whatever we are consuming here is what is going to be the actual usage. But when we go to this off, so when we go to this stage, so till here the actual usage is going to be whatever usage we can see in column D. But the moment we have this break here, the actual usage is going to be zero, right? The actual usage is going to be zero, and it is going to be zero till when? Till we have the next on statement here. So till here we are going to have zero, and now from here onwards it has restarted. So we would want to have a 7540 minus 7535 as the total consumption ever since it's gone on again. So why would we need this? This is required to see or try to understand the pattern as to how is a network failure. Do we have a particular trend after say 100 units of network utilization there is a power failure, or somewhere around 100, 90 or 110 or 120. So the moment it reaches somewhere that area, we know there's going to be network failure. So people in the network operations can be well prepared. Now that we have the network consumption somewhere close to that area, we should be prepared well in advance, take necessary steps so that there is no network failure. So that is the idea here. So for that, we are just trying to see after every network failure, and then once the network is on, what is the usage pattern. So here it is 5 units, 7540 minus 7535. So here it will be 7545 minus this number. So because we are going to have cumulative numbers here, and so I can just put a dollar here, double dollars, so that this number remains constant. So if I just copy it to the next line, it will be 2370 static. So we just have these numbers 7545 minus 7535. So we are getting these numbers cumulative. So even if I drag it, you're going to have a proper subtraction values and cumulative numbers getting calculated here. All right. And this is going to go how long? Till we have the next off statement, which is for a longer duration. So here it is. So up to this line, we are going to have this value cumulatively increasing. And once we have reached this point where these two values are the same, because there has been a network breakdown or network failure, this is going to be 0. And how long is this going to be 0? Till we have the next on status. So till here it's going to be 0. And then here the value is going to be 21945 minus 21940. So once again over here we are going to have this similar increase in the network usage, right? So if I just continue to project the numbers here, it is going to be cumulative increase. So you get the idea what the problem statement is and what we are trying to solve here. So if we see in Excel itself, it is being done manually here. So I'm not sure if we have any formula in Excel using the if or nested if, all the other complex formulae that we have in Excel, which can be used here to solve this problem in Excel directly. If there is a way out, please do let me know. I would also like to learn from you. Here anyway, our objective is to solve this using R and Python code. So in this tutorial, I will be solving it in R. Okay, let's head over to the R Studio now. Okay, to call this Excel file, we need to be in that particular working directory. If not, we have an option of going to that particular directory by clicking on these three dots here, and it will prompt you where exactly you want your working directory to be. Select that working directory, click on open, and it will show that working directory over here. And then you go to more and then set that as working directory. To read this Excel file, now this is an XLSX file. So for that, I need to have another library in my R Studio, which is read Excel. And if you do not have this library, you have to go to tools, install packages, and just type read Excel here, and you will have that read Excel displayed. Click on install, and you should have that installed on your laptop. So once you have that library, just call that library function, library read Excel. And now let's call the Excel file. So let me have the variable name as df, which is nothing but the data frame. And I would be using read underscore Excel, which is part of this read Excel library. Now inside this, I would be passing the complex EDA Excel file. If I just click on Control plus Enter, that would be good enough for me. However, please bear in mind that if you have more than one worksheets in Excel, you will have to specify another parameter, which is sheet. So you have to either give the name of the sheet, or you can put the proper sequence 1, 2, 3. In this case, I can just put 1 because that is the sheet number 1 and only sheet that I have. So even if I just put sheet equal to 1 and enter, it should give me the same results. If I look at DF here, I also got this thing incorporated, which I don't want to, because this particular column is something which I entered manually to explain the use case. So let me remove that from my data frame. Before that, let me just see, this is the fifth column that I want to remove. So if I just type df equal to df in the square bracket minus 5 and click on enter or the run button, it would now only have 4 variables. Let's just check that out. head df, and we just have up to usage. All right. Now we have to run a for loop right from the first row to the very end of that data frame. All right. So for I in 1 to number of rows in that particular data frame. When I'm running this for loop from the first row, what I have to do is I have to check if the value in the particular row is the same as the value in the previous row. So if it is the same, then I'll be incorporating actual usage as 0. If it is not the same, I would be putting these numbers as it is. But even there, we have a condition. So if df dollar usage, and if I look at the ith row, is this the same as df dollar usage in the I minus 1 row? So what I'm checking here is if I'm at this location now, this is the ith row, is this the same as the I minus 1 row? Now, if I do this, if I'm on the very first row, it cannot check in the 0th row because there is no 0th row. So what I can do here is I can change the for loop from 1 to 2 instead. So I'm saying I'm running the for loop from the second row, but I'm checking if the value in the second row is it the same as the one in the first row. So the value in the second row, is it the same as the one in the first row? It is not. So we are not going to look at it right now. We are only going to look at what if it is the same. So this case. So if this is true, value in the I plus 1th row or ith row, is it the same as the value in the I minus 1th row for usage column? So if it is the case, then I have to put actual usage as 0. So what I can do here is, now I don't have any actual usage field here, right? If I just look at the names here, so these are the 4 columns I have. So I don't have any new variable actual usage which I'm trying to bring in actual usage. So what I can do here is I can define or assign this value as 0 at the very beginning. So once I assign this as 0, now all the values in that particular column will have zeros. So if I look at df now, it will have all these 0 values there in. I did a big mistake. I should have actually changed it to actual usage. All right. So I think I have to execute this all over again. Now I also create a new variable usage, actual usage. I have 5 variables now. So if I again look at head, so I have the 5th variable, which is now 0 all across. All right. Now I'm running this for loop. So if this is the case wherein you have the ith value and the I minus 1th value as the same, then you have the actual usage as 0. So since we have already defined it as 0, we don't have to worry about it. But we will have to do a small thing here. We will have to maintain that value in some temporary variable. I'll tell you why. For now, let me just maintain that temp is equal to df dollar usage I minus 1. So what I'm doing here is the I minus 1th value. This is I minus 1. So this particular value is what I am storing in the temporary variable. Now, if this condition is not true, that is if the ith value and the I minus 1th value are not the same, then what do we want to do? Else df dollar actual usage for that ith row should be the same as df dollar usage in the ith row minus 10. Now let me explain what exactly I did here. So let me go to this particular column where we have the next on coming, right? We have this on here. So what are we trying to do for this particular line? How are we trying to bring 5 here? Now till here, what is happening is whenever this for loop is getting executed till we reach this particular row 2370, this if condition will be called, and at that time the temp value would be I minus 1, which is nothing but 7535. Even when this particular row is now called, 2371. The temp value is 7535. Correct. So when we come to the else condition, that is when the ith row value is not the same as the I minus 1th row value, it would come here and it would say the actual usage, this particular value should be this value, which is usage, df usage I minus. Now, what was the last value stored in temp? It was this value, 7535. So 7535 will get stored here. So it will be 7540 minus 7535. That's how we get this value. And then again it will continue. So now it's 7545 and 7540 are not the same. So that is I and I minus 1th row values are not the same. So what would it do? It would not follow this. It would just be following this particular else condition. So actual usage, once again here, 7545. So in this actual usage, what would it do? The ith value, which is usage I, minus temp. Temp is once again 7535 itself. So it would do 7545 minus 7535. So temp. Again, the next record, df usage I. So df usage I minus temp. So temp is this 7535. So it will be 7550 minus 7535, which is 15. So on and so forth. So again, once again, when it approaches the case where we have another off, where we have two values as the same, what would it do? It would do the same thing. So here both are the same here, so it will retain 0 because we have already initialized actual usage as 0, and at the same time the temp value will be df usage I minus 1. So we are in the ith row, so I minus 1, actually both are the same, so we are going to maintain 21940 in the temp variable, so that once we go to the next on condition, so here if we have to calculate this particular value, now since ith row value and the I minus 1th row value is not the same, then we are going to have the value as 21945 minus the temp value, which is 21940, which is 5. Similarly, here again it is not the same, so it will be 21950 minus the temp value, which is 21940, so it will be 10. So that's how the calculation goes on and on. And now let me just execute this for loop. Once I click on the run button, temp, I have to also assign some value for temp. I have not used this temp because sometimes when you're running this for loop, it might not even execute this if condition first, because when we are running this for loop for the first time, this condition will never be true, right? Because here the ith row and the I minus 1 row are not the same, so this if condition will never get executed. So it's always better to assign a value for temp as well as 0 here. In fact, we can do it here itself, equal to 0. We can do it this way as well. Okay, now let me just run this file all over again. So now if I look at df, this is my data frame. So I have all these values as it is. Let me just go to my Excel file as well, and let me go to the off record row 1510, which is 1509, because we also have a header here. So 1509, let me go to 1509 here. If I just scroll down, so 1509 is 0, and all the way it will go on till which row? Till 2369, I guess. So let me just keep going down. Yeah, 2369, it's 0, and once again it's starting from 5, because 7540 minus 7535 is 5, and 7545 minus 7535 is 10. So we are getting these values as it is, 5, 10, 15. So our formula is working perfectly. And this is a use case which I came across in one of my recent case studies. So I just thought of sharing it with you. If you find a better, more economical way of solving this problem, this use case, please do share it in the comment section. I would also like to learn from you. But this was my thinking and my way of solving this particular use case. I hope you found this useful. If you have any questions, suggestions, feedback, please do post them in the comment section. Thank you very much. See you in the next tutorial.